Hello everyone, welcome back to day 2 of Unit 1A. Today we're going to be talking about scientific notation. So you probably already did scientific notation last year, or at least got a little intro to it. We're just going to go over that again, and yeah, that's really it. Let's go ahead and get started. So the vocab for this day of notes, I guess, is actually pretty small. All we need to do is define standard form and scientific notation. So standard form is the actual number with no multiplication symbol. So all the numbers that we deal with on a normal basis, those are standard forms, like straightforward numbers. That is our standard form of numbers. Okay? However, we might use different ways of writing numbers depending on what's going on with that number. So scientific notation is another way of writing a number. It is used to abbreviate either a very large or very small number. So when you have a really large number, instead of writing all of those digits out, we can use scientific notation. Or if it's really small and it's a lot of numbers behind a decimal point, we can again use scientific notation to abbreviate it. Okay? So but this is what it's going to look like, sorry. Scientific notation always looks like some number times 10 to some kind of exponent. Okay? That's what allows us to that's the abbreviation. And this number is always going to only have one number in front of the decimal point. It has to have one number in front of the decimal point. I could have a lot of numbers behind it, but it has to have one in front. And this exponent can be either positive or negative. But that exponent tells us a lot about changing it back to standard form. And even when it got changed into scientific notation. So let's go ahead and talk about converting from scientific to standard. So when we have it in this form, if the exponent with this 10 is positive, that means we're going to move the decimal point that's with this number. We're going to move it that many spaces to the right. So say the exponent was 3, we're going to move the decimal place 3 spaces to the right. Okay? If the exponent is negative, we're going to move the decimal point to the left that many spaces. So again, if it was negative 3, we move it over to the left. And it's really important that you notice what happens when you move it to the right and to the left. If it was positive and we move it to the right, it actually makes our number bigger. But if the exponent was negative and we're going to move the decimal point to the left, it would make our number smaller. Okay? So let's try an example or two, and then you guys can try some on your own. We're going to express each number in standard form. So here we have 2 times 10 to the third. So we have our number times 10 and our exponent is 3. Okay? So that means we're going to look at the exponent. It's positive. We're going to be moving the decimal point 3 spaces to the right, according to our notes here. However, there's no decimal point. So what happens is we write out the number, and we just put a decimal point behind it, right there. So to move it 3 spaces to the right, we're going to go 1, 2, 3. And if there are no numbers to put in there, like we're not moving it around numbers, we're just moving it spaces, we can go ahead and put in zeros. So since we were moving that decimal point over 1, 2, 3, so now it's over here, that changes our number to be 2,000. The decimal point is in the back now. So it enlarged our 2 to 2,000. Let's try it again with this one. We got 3.025 times 10 to the negative 7. Okay, so our exponent is negative. That means we're moving it to the left. So we're going to start with our number, 3.025, and we have a decimal point in here. So now we're going to move it to the left 7 spaces. So 1, 2, 3, 4, 5. 6, 7. Sorry, we're a bit short on here. 6 and then 7. So when we do that, again, all those little humps that we put in there, it's going to have a number. We're going to fill in with zeros. So we put a 0 there and a 0 there. And now our new place for the decimal point is over here. So that changes our number to be, not this. This is wrong. Well, I can't delete it. Yeah, I can. I should be able to delete. There we go. It changes our number to be 0, or point, yeah, 0, ooh, goodness, 0.0000. Did I count right? One more. 1, 2, 3, 4, 5, 6 zeros. 3025. And now I'm just going to make it so you can see the whole thing. It's a very long number, which is why we like scientific notation, right? It makes it a lot smaller and a lot easier to write. And I'm just going to fix it really quickly. There you go. So, you can see that was to write it in, all these things are popping up, sorry, 3.025 times 10 to the negative 7 is a lot easier than trying to write it out with all those zeros. Okay, so now you guys are going to try it on your own right here. Okay, you can wait till the end of the video or you can pause it and do it right now. It's up to you. We will go over these next class. Alright, so now moving on to converting from standard to scientific. Guys, don't forget, if I'm going too fast, you can easily pause the video and then take your time and write it, rewind if you missed something. That's all you gotta do. Okay, converting from standard to scientific. So you have a normal number and you want to write it in scientific notation. You're going to do 3 steps. You're going to move the decimal point so there's only one number in front of the decimal point. Okay. You're going to multiply that number by 10, and then you're going to add the exponent to the 10. The exponent is going to be how many places that you move your decimal point. Now, something else you need to consider is if it's going to be a positive or negative exponent. So if the original number is greater than 1, the exponent is going to be positive. So that means if it's a big number, basically. If you're making it smaller by moving the decimal point to fit into this step, the exponent is going to be positive. If the original number is between 0 and 1, so it's a small number, and you're moving that decimal point to make it bigger, then the exponent will be negative. Okay? I know, you're going to have to practice with it, but that's why if you make sure you pay attention to what's going on when you move the decimal point, you can work backwards here and try to see what's going on with the exponent. Alright, let's try an example. Express each number in scientific notation. So we have 4 million, and then we have 0.000986. Okay, so let's start with 4 million. We need to make this so that it's only got one number in front of the decimal point. So currently, the decimal point is here. We need to go 1, 2, 3, 4, 5, 6 spaces. So we only have the 4 in front. So now, because I had a large number greater than 1, and I'm trying to make it smaller, so I'm turning it into a 4, that means my exponent is going to be a positive 1. Okay? So I'm making it smaller here, so it's going to be a positive exponent, because when I apply it, it's going to make it big again. So I'm going to have 4.0 times 10 to the 6, because I moved the decimal point 6 spaces. Okay? Let's try this guy. So notice it's a small number, so the original number is going to be between 0 and 1. So basically it's starting off as like a little itty-bitty decimal. That means that the exponent will be negative when I do this. So when I move my decimal point, it's going to be a negative exponent for my scientific notation. So I'm going to go ahead and move it because I only want one number in front. So I only want this 9 in front of the decimal point. So I have to move it between the 8 and the 9. So I'm going to move it 1, 2, 3, 4 spaces. Okay? Move it over 4 spaces. So that means my exponent is going to be a 4, and because it was between 0 and 1, and I'm trying to make it into a bigger number, I'm trying to make it into a 9, it's going to be a negative exponent. So I have 9.86 times 10 to the negative 4. Okay? So you guys are going to try these two on your own. We will go over them next class. If you have any questions, feel free to write them down as you go. Okay? But that's it for the video. I will see you guys next time. Bye.